Okay, so we'll start with just kind of our basic process. It's a 4-step process. You don't have to number the steps or anything like that. It's mostly just these are the 4 steps you need to think through. And so I'll be looking for these in your solution, all 4 of these to be done, but you don't have to explicitly label them or anything. So the first thing we always do is to identify the unknown and assign them a variable. So what I always do is ask myself, like, what things in this problem are represented by numerical quantities, and those are the things that I'm going to list. So I always list them in words, and really the key to any application problems is to label everything. And again, today, this might feel a little bit like overkill, all the labeling we're going to do, because the problems are fairly simple. But I promise you that when the problems are more complex and you have to do a whole page of calculations and solving and plugging in before you actually go back to like finding what you're trying to find, you're going to be glad that you have a list at the top of all the facts and what everything represents. Because it's easy to forget all of the whole sentence or paragraph as you go through all the work for the problem. So then once we've labeled, we're going to translate the problem into an equation or system. We're not doing systems of equations today, but in general, we can use these same steps for problems that involve systems. Then we'll solve the equation, and then we're going to answer the question with a sentence. So this last step is really just like you want to answer the question like as if you're talking to someone. So you don't have to like write me a novel. Like it's not about like how much you write. I just want it to not be math, right? Like if somebody asks you how old you are, you wouldn't be like x equals 18. Like nobody talks like that, right? So you don't want any variables in that sentence. You don't want any equal signs in that sentence. You just want to like ask yourself like what you would say if somebody asked you the question in words, and that's what you're writing for that sentence. So it doesn't have to be super detailed, just not math, English instead. Make sense? Okay, so again, we're starting out with something fairly simple, but let's go through those 4 steps so we can start developing this algebraic process. So I'm going to look through or read through the problem and then ask myself what things are represented by numerical quantities. So when I say represented by numerical quantities, I don't necessarily mean they give me a number for it. I just mean that it's something I would use a number to express. So in this case, we have the width, the length, and the perimeter. And when I think about problems like this, I think about like that I can express everything in the problem in 3 different ways. I can express it in words, which we just did. We can express it using algebra, which is using variables. And then you could express it in numbers. So like, for instance, the perimeter is 228 feet, right? That is a set number, right? It's not an unknown. It's not a variable. So that's not algebra, that is numeric. 228 is my perimeter. However, they don't give me a number for the width or the length, right? So those are unknowns, and that's what we're going to use algebra for. So which one of those do you want to be your variable? So like if we're just going to have one variable, we'll call it x. Which one should I? Length. So we chose length because the width is given in terms of the length. So if we knew the length, what would we do to find the width? We'd subtract 42, right? So whatever my length is, the width is 42 less than that. So the whole idea of using equations to solve application problems is based on this idea that we can like write an equation, right? And so when we write an equation, what you want to think about is what they give you a number for. So in this case, they give us a set value for the perimeter. And in order to write an equation, we're going to express that same quantity algebraically. So using what I have for my width and length algebraically, how would I write a formula for the perimeter of this rectangle?
Wouldn't it be like 2x plus 2 times x minus 42 equals 228?
Yep. Good. Equals 228. So on the left side of that equation, I express the perimeter algebraically, and on the right side we expressed it numerically. So if you're ever unsure of how you're supposed, like what formula you should use or what your equation should be about, think about what they give you a number for. So what they give you a set value for, and then be like, okay, let me use my variables to build an expression that represents that as well. And then those 2's are there because there's 2 lengths and 2 widths. You could also just add the 4 sides. Like you could have written x minus 42 plus x minus 42 plus x. This is a little bit easier to write, but either way is fine. And then we'll solve. Good? So 2x plus 2x minus 84 equals 228. So 4x equals, minus 84 equals 228. The good news about these problems is that most of the equations are fairly simple to solve. So once you get through all the work of setting it up, the equations themselves don't get too messy. This is what, 312? So x is 78. At this point, once you solve the equation, you want to pause for a second and just ask yourself what you found. It can be one of the most valuable steps of this whole thing, is just to like recognize what it is you found and then figure out what the question is actually asking for, because the question's not necessarily asking for what you represented x with, right? If they had said, what is the width of the court? Well, it's not 78, right? Because what did we just find when we found x equals 78?
The length.
We found the length, right? What are they asking us for? What does that mean?
Everything.
Right, the length and the width, right? Like the dimensions of a piece of paper are like 8 by 11.5, right? So length by width. You don't even have to, in your sentence, you don't have to like be like the width is and the length is. You can write like this by this. In math, generally, they call the length the longer side, and then the width is the shorter side. But, you know, when you pick up a piece of paper and tell us the dimensions, you're not like, the width of this piece of paper is 8 inches, right? You're like, this is 8 by 11.5. So it doesn't, again, that sentence doesn't have to be like uber detailed. It just has to answer the question in a way that makes sense in English. So if my length is 78, that means my width is 36. So just subtracting that 42. And so the court is 36 feet by 78 feet. When I look at that last step, your answer as a sentence, the things I look for are, again, that there's no math symbols, and then that you answered the entire question that was asked. And really, like, I don't usually take points off for this, but realistically, you want to answer only the question that was asked. Like, if there's a problem about, like, you know, one of your sisters is this many years older and one of your sisters is this many years less, like, you don't, and then it says, how old am I or something? Like, you're not going to be like, my sister's 28, my dad's 56, my brother's 16, right? You're going to be like, I am this old, right? If somebody asks you how old you are, you're not going to list the ages of everybody in the family. So even if the problem gives you a bunch of information, like, you just want to answer the question that's asked. So I look for an answer to what was asked, and then units. Make sure that you put units on there. So if you said 36 by 78, I mean, it could be 36 miles by 78 miles, right? That's a very large rectangle. Make sure that you specify what the units are. Questions so far? It's a basic process, makes sense. Okay. In general, when we do problems like this where we're relating more than one unknown, I look for 2 pieces of information. So I look for one piece of information that relates the unknowns to each other, and then one piece of information that relates the unknowns to some other number. So like in our first problem, when they told us that the width was 42 feet less than the length, that relates my 2 unknowns to each other, right? Nothing else is involved. And then when they told me the perimeter, that related the width and the length to some other number that I know. So sometimes, like in a problem like this, it seems like there's not a ton of information there, like it's a really short sentence. And so it can be helpful to think about those 2 things. So how are the unknowns related to each other, and then how are they related to this other number that they gave me? So my two unknowns are like the first number and the second number. And then what piece of information tells me how they're related to each other?
Consecutive.
Yeah, that they're consecutive, right? That piece of it, the way they're related to each other, has nothing to do with the number 97. So we can even just ignore the number 97 for a minute and be like, okay, how would I express one in terms of the other? What does it mean for two numbers to be consecutive?
Oh, they're like one after the other.
Yeah, they're one after the other, right? So if the first number is x, the second one would be x plus 1. I always make the smaller number x. Like, if you felt like it, you could make the larger number x, and then the smaller one would be x minus 1. Doesn't matter as long as you're consistent. And then how are they related to each other? Or sorry, not to each other, to this other number, 97. What is 97?
It's the sum of the two.
Yeah, so this is our sum. And because that's what they gave us a set value for, we are going to express that sum both algebraically and then set that equal to the numerical quantity they gave us. So algebraically, the sum is just the two unknowns added together. And then that is equal to the value we're given. So 2x plus 1 equals 97, which means that 2x equals 96. So x is 48. What did I just find? The first number, good. And you can put it in your table. And you don't have to do like a little table like this. You need to, like, I need to see at least this much. So like where you're labeling your unknowns. But if the table's not helpful, you don't have to organize the information that way. So if the first one is 48, the second one is 49. So one more. And so my numbers are 48 and 49. And again, you don't have to write a big long sentence, just as long as you're answering that question. Any questions on that one? Okay, you guys try the next one. Notice this word right here, that they're consecutive odd integers. So think about how odd integers are related to each other as you set this up. And then one thing we always want to talk about when we are doing application problems is like where this model is realistic. So people always ask like how math is used in the real world. Things like this are exactly how it's used. And honestly, like every single thing you do all day has to do with something like this. It sounds like an exaggeration, but like when you're driving on the freeway and you go around a curve at 80 miles an hour, like that same curve, if it was on a flat road, you couldn't go around at 80 miles an hour, right? You have to slow down to like 20. The reason you can go around that curve at 80 miles an hour is because somebody came up with a formula that tells them how much they have to pitch the road in order for you to go 80 around that curve instead of 25, like you would have to do in town. Like when you go shopping, the number of people that are working at the store, the managers, they observe like how many people come in at different times, and they use a formula to figure out how many people they need working to accommodate all the customers. Like every single thing people decide in like business and architecture and everything is just observing past data and then generalizing it for future use so that they can make predictions. That's why we have like a census, right? So that they can analyze all the past data and then make predictions about what our country needs, or we won't get political. But these models don't always make sense. Like they don't make sense for every single number, right? Usually the models have some restriction. Like for instance here, can I plug a negative number in for x? Would that make sense? It wouldn't, right? If I put -2 in, that would not make sense for this problem at all. So this model is only going to positive, right? So greater than or equal to 0. But like, what if x was 0 or 1? So if you used 1 gigabyte of data total, how much would you pay? 40. Now, what do you get if you plug 1 into that equation? Yeah, you get 30, right? Because 2 minus, wait, did I say 1? Sorry, you get 20. Because 1 minus 3 is negative 2 times 10 is negative 20 plus 40 is 20, right? Which isn't accurate because, unfortunately, they don't give you money back for data that you don't use, right? So that's the reason we got 20 is because this equation basically says if you use less than 3, they're going to give you back $10 per gig, which isn't true. And so this formula actually isn't realistic unless x is greater than or equal to 3. And like that doesn't mean there's anything wrong with it. Like the fact that a model doesn't always work doesn't mean it's a bad model. In this case, like I don't really care if I have a formula for how much I'm going to pay if I use less than 3 gigs because I know it's 40, right? Like you don't need a formula for that. And so the only thing we need an equation for is beyond 3. And so it's okay that it doesn't work for every single number. It works for what we're trying to express here. But you always want to think about that when you relate different unknowns with an equation, is like what it actually works for so that we know our model is realistic. Okay. Part C, if our bill is $125, how much data did we use? So when I have an equation that relates two unknowns, the way I always think about it is if I'm trying to find something, they have to give me the other one, right? So here they are asking me how much data I used. So how much data, that tells me to find x. And if I have to find x, they have to give me c. So no matter what's going on, I mean, it's fairly easy or fairly obvious in this one what C is, but sometimes the sentence isn't quite as straightforward. But something in that sentence has to tell me what C is, or else there's no way to find X, because those are the only two things being related here. So this 125 tells me that C is 125. And that's another step that it's worth slowing down and saying, okay, what does this mean and what does this mean? So like, what am I finding and what am I given? And then we can use our equation. I'm sure you guys all solved that while I was talking. What is it? What'd you get for X? Nobody? It's okay. Speak up. Tell me your name again. What's your name again? Peter. What'd you get? I can see that you did it.
11.5.
11.5, thank you. So 11.5 gigabytes. Realistically, your bill would never be 125 in this situation, because those dang companies don't like charge you, like they don't prorate it, right? As soon as you go over, they're like, bam, $10. Here's another gig. My kid goes over a lot, so I've experienced this. But if they did, we would have used 11.5 gigabytes. Make sense? Okay, you guys do this one. This is really big. I'm not gonna lie, guys, like when I was in high school, every single assignment had like 2 word problems at the end. And when it looked like this, I was just like, screw it. Like I just skipped it, because who wants to read that big, huge paragraph? But you guys aren't gonna do that, because you're mature college students and not a dumb high school student like I was. The key, though, to deal with these big, huge, obnoxious paragraphs is to only read them once. And the way that we can avoid having to go back and read it over and over again is, again, that labeling. So just label what your unknown, or write down what your unknowns are, label them with variables, and then you can throw the rest of that away. This one is kind of nice because they give you the equation. You don't even have to come up with it on your own. You just have to write down what the variables represent and then do A and B. So again, it might feel a little bit like overkill on this one to make this list and do all this labeling. We're going to do it because we're going to get in the habit. So when I look at this equation, the first thing I do is say, okay, what are my variables? And I just list them. So x and y are the variables that are in the equation. And then you want to go through all of those words and be like, okay, well, what does x represent? What does x represent here?
Age.
It represents age. That is true. Now, if I write this, and then I go do like 30 pages of math and I come back to it, when I read x equals age, I think that if somebody's 20 years old, x would be 20, right? Is that true? So let's be a tiny bit more specific, just so when we go back to this, we know exactly what it means. So how do you get x? Yeah, so x is like the number of years of age over 40, right? So years over 40, or years past 40, or age past 40, whatever is going to tell you that it's the number of years after 40. And that way, no matter how much we do to distract ourselves, we can always go back to this and have something that reminds us of exactly what x is. And then what's y?
The total.
Mm-hmm. Yep, our total cost or total premium. And how are we measuring the premium? Like, what are our units?
Monthly.
Per month. And dollars, right? So dollars per month. And I always think about that only because sometimes we don't measure it in dollars. Like, a lot of times when we're looking at things on a larger scale, like a national scale, sometimes we have numbers that are like in the billions. And so rather than y being the number of dollars, it'll be like in billions of dollars. So if you get 25, it really means 25 billion. And this would be a place to take note of that. So like later on, if you get y equals 25, you know it's actually $25 billion and not just $25. So after that, I think so we are finding the premium, which means we're finding y, which means they have to give me x, right? So I look for the piece of information that gives me x. So x is 8, y equals 8.33 times 8 plus 32.81. And if you took 065 last semester, you're probably used to not using a calculator. And so it's not like what you're reaching for right now, which is good because your calculator should never be the first thing you reach for when you do a math problem because there's all this setup to do first. But once you get to this point, you don't have to write down a bunch of steps. Like, just plug that whole thing in your calculator all at once and hit enter, and it'll spit out a number, which is what? 99.45. So the premium is $99.45. And then for part B, again, they ask what issue age. So that tells me I need to find x. And so I think to myself, if my equation relates x and y, and I have to find x, then something in this has to give me y, which they do right here. So we have 167 equals 8.33x plus 32.81. And somebody solved that and got what?
56 years old.
So what's x? Yes, the answer is 56.
Oh, okay.
But what's x first? Yes, so we got x equals about 16, which again, going back to what X represents tells us that the age is 56 years old. Excellent. And that last problem we're just going to do tomorrow. It's not on tonight's homework because I kind of expected we wouldn't get all the way through it. So just hang on to that for tomorrow. And